think I can turn it on.
Oh, no.
I'd like to get a thumbs up from anybody that's heard of the U.S. National Grid already. You've got the reactions button down at the bottom. Give me a thumbs up or something like that. 1, 2, 3. Counting them off. Everybody's finding that reaction button down there. All right, a few people have heard of it. Most of you have not. Well, that's certainly interesting. Let me, I'm going to start up my PowerPoint and share my screen. Let's see, I need to share my screen first. Let me get this figured out and start the PowerPoint. Can everybody see my slides now? Can somebody give me a positive? Okay, great. All right, well, this presentation is an introduction to the U.S. National Grid. I've given this to a variety of different audiences, including first responders, emergency managers, as well as GIS professionals. And in this case, I believe the audience is primarily GIS folks, GIS familiar folks at least. And we have a few people that have actually heard of this as well. The first several slides are universal. I've given them to emergency managers and first responders as well as GIS folks. So those of you that already heard of it, think about how you can actually present this topic to your own first responders and emergency managers. So I'm just going to run through that, and after we get through the first few slides, then I'll start to editorialize a little bit with some of the GIS context. So when we think about GIS, you know, emergency managers, first responders are becoming more aware of what GIS is. It's years ago, I really got started with this about 10 years ago or so. And at the time, you know, they kind of knew what GIS was. We made maps, but they really thought we did magic. And, you know, all of the stuff that we can do with the 3D modeling and analysis and things like that are certainly really great tools to have available to us. But when we think about GIS for emergency management, it really applies in a variety of different ways to each of these different phases of emergency management. In the response phase after an event occurs, we can use GIS to assist with damage assessment, search and rescue. In the recovery phase, where we're really trying to bring things back to normal, we can track status and track resource deployment. And then after the recovery, when we're in the mitigation phase, trying to find ways that we can minimize the impact of such an event, we can help with the analysis. And then in the preparation phase, where we're preparing for the next event that might occur, we can help with all of the planning. But right at this point between preparation and response is where an actual event occurs. And what we need to think about with all of this technology that we have, what can we do with the least amount of resources and most effectively and most reliably in a worst case scenario? And that's what we're starting with. And that's maps. You know, we've kind of thought about, or kind of forgotten about maps and GIS. GIS is all about the cool applications and analysis and things like that. But at a fundamental level, we make maps. And it's not just about making the maps, but it's about training first responders and emergency managers on how to use these maps. And so it's integrating GIS and teaching, or GPS, and teaching basic map reading and land navigation skills to first responders and emergency managers. That's what we do at a fundamental level. And so it's really just about teaching them to really pay attention to those numbers that are around the edges of the maps. You know, you're just putting coordinates on a map, and you simply read right and then up. It gets you to a certain location, a grid square on a map. You refer to that by the numbers. 7556 refers to that grid square. Very simple. And then we can have additional maps. We've really created two different series of maps. The large map is at a scale of 1 to 24,000 scale, 1 inch equals 2,000 feet, and a size of 22 by 24 inches. The smaller map is 8.5 by 11, 1 to 6,000, 1 inch equals 500 feet. And so what that gives us is really a 4 times difference in scale, where at the 1 to 24,000 scale, we can really show a region and show things like major roads and major point features. When we look at, and when she goes 500 feet, now we can get down to the detail of showing addresses, street names, fire hydrants, and things like that. So we can teach them very easily. If you go to find a grid square on the large map and you measure and determine the name of that 7456, that gets you to a page in a map book for the detailed information. And then when you look at the detailed maps, these are 8.5 by 11, we can again refer to an area on that map by simply reading right and then up, adding another digit to that grid reference. And so now we have 741565 describes this area on the map. Well, so all of those detailed maps then can be put together to form a map book. So we have the standard map index, and we have a series of maps that cover the entire area. They all look the same. They all are numerically ordered, so it's very easy to find the pages in the map book and so on. And then if we want to get more detail on those maps, we can interpolate on the map very easily to get basically a 10 by 10 grid within that square. We add another number to that grid reference, and now 74135658 describes that location on the map. So it's very easy to teach this to anybody about how to relay locations, measure locations, and relay those locations. Well, this map number or this grid numbering system is a part of a national system, covers the entire US, and it's called the US National Grid. The US National Grid has been around since 2001. It's nothing new. It's been adopted by several federal agencies. This is the Federal Emergency Management Agency, the Department of Homeland Security, the National Geospatial Intelligence Agency, and the United States Geological Survey. Significance of this is that the first two, FEMA and DHS, are the emergency management side of the federal government, and NGA and USGS is the mapping or geospatial side of the federal government. Both have adopted it as a standard. It's also been adopted by several states. I list them there. Was adopted by Minnesota as a standard in 2009. I encourage all states to pursue that same kind of standardization. It is, in fact, the military grid referencing system. So not only has it been around since 2001 as a national standard, it's been around since World War II. This is nothing new. This means that when we teach people how to use the MGRS, they will be directly interoperable with the National Guard and all NATO forces. And in fact, this is nothing more than UTM coordinates. It's a shorthand notation for UTM coordinates, been around forever. So really what this is about is creating maps and teaching people how to use the maps using well-established conventions that take care of all of the geospatial and projection details that are familiar to us, but unfamiliar to them. So this is why on the US topo maps and USGS quadrangles that have been around forever, we see the grids labeled in this way, where we see the full UTM coordinates, and then you see the principal digits only labeling the grids after that. So the 82, 83, 84, 85. That facilitates the use of these maps for the military grid referencing system, the US National Grid. So it all works. And we make our maps the same way. It's the same convention that's been around forever. We also include this information that you see in the lower left corner, where we have the standard grid, the size of the grid. We reference the US National Grid, the grid zone designation, and this grid zone designation box. That's all a part of the standardization. So if we take another look at this, if you look closely, what you're seeing here is actually UTM zone 15, and it's actually broken into 6 degree by 8 degree quadrangles. So now it's still all UTM zone 15. What we're doing is just breaking it down to smaller pieces. And then behind that, you can see squares, and they're labeled using 2 alphabetic characters. And if you look closely, if you can see it, there's a column of V, and then a column of W, and then we can see rows of A, B, C, D, E, F, G, and so on. So these are all the even 100,000 meter increments of the UTM grid. And so it's just a shorthand notation, and it's really all about, once we get down to a detailed level, we have this overall reference of where we are, but we don't need to keep referring to it all the time. And that's where the efficiencies come in. In fact, if we look at something like 100,000 meter grid BK, it doesn't exist for 800 miles in any direction. So if we know we're working in Minnesota, for example, and we know we're in 100,000 meter grid VK, we can almost not have to say 15T anymore, or UTM zone 15. We're in the 100,000 meter grid VK. It doesn't exist for 800 miles in any direction. So that's where the efficiencies come in, as well as making sure that we're able to refer to these without ambiguity. So here you can see, okay, VK is unique for 800 miles in any direction, sorry. So the US National Grid coordinate format, this is the full US National Grid reference. It's 15 characters, and we're going to break it down into its components. This, in fact, is the shorthand notation for the UTM coordinates, where we have to say UTM zone 15 north, 492,220, 4,976,580. And we have to use all of those numbers in order to properly reference a UTM position. But if we start to break down this UTM or this US National Grid reference, the first three characters are the grid zone. The next two characters are the 100,000 meter square. And then we have an easting and a northing, so X and Y. And those are in even numbers, don't go to decimal places and things like that. And these are always going to be in meters. Now, this is the first time that I say meters, all right? It has a tendency to scare people. And so once we get through all of that and explain the logic of how this all works together and how you can use different number of digits to represent a different level of precision, it really doesn't matter if it's meters or feet or whatever units you choose. Meters actually work very well because the numbers aren't so big. Plus, it's pretty easy to just relate to it as approximately the size that a human takes up on the ground, or one giant step, or about a yard. 100 meters is about the size of a football field. It's really not that big a deal. People should not be scared just because it's in meters, and you just need to move past that quickly. So let's look at this in more detail. The 15T is the grid zone. Grid zones are 6 degree by 8 degree portions of latitude, longitude, even intervals. And then the next is the 100,000 meter square, 100K square. And that is an even increment of the UTM coordinate system. The lower left corner always describes that square. We go further, the first digit is going to be a 10,000 meter square. And again, the lower left corner, the UTM coordinates of that lower left corner describe that entire square when we're only using those two digits. We had two more digits, now we're down to a 1,000 meter square. Two more digits in X and Y, we get to a 100 meter square. Finally, a 10 meter square, and then at the end is a full 1 meter designation. Now we can drop off whatever digits we need to represent whatever level of precision are necessary for a given application. And it may vary. If you're just trying to describe a landing zone for a helicopter, if you get it to 100 meters, that's probably going to be for that. Flares or flashing lights or something like that, So we can choose the level of precision and the number of digits that we need. The precision is implied by the number of digits, and that's one of the efficiencies that come into play. So if we look again at the full 15-character US National Grid designation, the US National Grid, one of the differences between the US National Grid and the military grid referencing system is US National Grid allows for spaces just to add clarity. Military grid by definition does not. So that's one difference. So you can have spaces or not have spaces in the US National Grid reference. It really doesn't matter. The full designation is to 1 meter, but then we can either truncate on the left or on the right, depending on the application. So if we use a grid reference of UJ2306, it assumes the grid zone. So we assume that whoever is using it, whoever is getting this grid reference knows which UTM or which grid zone we're in. And once you're working at a local level, that's a reasonable thing to do. So you start to get these efficiencies. The UJ is a 100,000 meters squared, 2306. Just because we have 4 digits, 2 digits in X and 2 digits in Y, it automatically implies that we're talking about a 1,000 meter square, defined by its lower left corner. And if we take off the UJ, and now we have 2337-0651, we're automatically implying 10 meters of precision, and we are assuming the grid zone designation in the 100 kilometer square. And those are all legitimate as long as you're careful, of course. But once you're working at a local level, it's fine to just use the numbers. That's sufficient. So why do we need this? You know, when we're talking about, we can make maps that have a logical numbering system. We can do grid referencing and be able to describe different size areas based on the number of digits. But what it's really all about is training first responders, emergency managers, and how to use this system. Have something like this. We have nothing but a continuous debris field. We've lost all visual cues and physical references in the field. You can't tell, you don't have street signs anymore. You don't have addresses on buildings. You can't see where a building started and stopped. You don't know what buildings were out there. And now you have to have some way of finding out where you are in this mess. And if you overlay a grid on top of it and couple that with GPS and maps, now we have something that we can relate to. So it's about creating maps that show the way things are currently and include things like the key resources, critical infrastructure, vulnerable population on those maps. Teach them how to use GPS or use their smartphones to be able to have the appropriate settings for their locations, and then be able to measure on those maps. And now they can navigate to a location that maybe had a pharmacy or a daycare, or as they are clearing an area, they can simply check off boxes or squares on the map as they complete their work in the field. And so it's a way to really start to relate all the information that we have to GPS and be able to use that in the field. So what about lat long? This is always the question. You know, I've got GPS on my smartphone. I can do lat long. What's the big deal? Why do I have to use this funny system with letters and numbers? Well, lat long is not intuitive. It's degrees, minutes, seconds. It's a base 60 system. 60 seconds in a minute, 60 minutes in a degree, 360 degrees around the Earth. It's just not intuitive. Plus, there are several formats. We can refer to latitude, longitude as degrees, minutes, seconds, degrees, minutes, decimal minutes, degrees, decimal, degrees. If you are relaying a location using one of these systems and the person on the other end misinterprets how you are conveying that location, it could be 50 miles off, and that's a serious problem. So that needs to be understood. Plus, when we're talking about degrees of longitude, we can express that as a positive number or a negative number, depending on which direction you're going from the prime meridian. Or we can call it a west longitude or an east longitude. If you're using a west longitude or a negative longitude, the numbers actually increase from right to left, which is counterintuitive. Well, then finally, how big is a degree? Well, the Earth is round, right? Well, the reality is that the size of a degree varies. At the equator, a degree of longitude and degree of latitude is approximately 69 miles. At our latitude, Minnesota, Wisconsin, it's about a degree of longitude is about 50 miles. A degree of latitude is still 69 miles. Then because degrees of longitude actually converge at the poles, they continue to get smaller and smaller until you get to the pole. Well, this makes distance calculations difficult. Now, of course, we can all find a calculator on the internet, and we've got apps that'll do that on our phone, but it's not something that you can visualize very well, because if somebody just gives you two locations in latitude, longitude, and you're trying to imagine the relationship between those 2 points, it's very difficult to do. You always need to take these other issues into account. You know, if we think about it down at a local level, 10 meters is about 0.5 minutes or seconds of longitude at 45 degrees and 0.3 seconds of latitude. just not something that you can really visualize in your head. And at a detailed level, the other thing is knowing if you're whatever units you're using, your degrees, minutes, seconds, decimal minutes, decimal seconds, how many digits do you need to accurately describe the location? And you need to know that. And it obviously depends on which latitude you're at. Well, the US National Grid is in meters all the time. And this is because we're using a universal transverse Mercator projection. So again, a very complex topic of using map projections is presented in a standardized, uniform way that nobody else needs to really worry about. And so that's what this is really all about. Standard common practices in mapping presented in a logical way and uniformly across jurisdictions so that everybody's doing it the same way. Well, if we look at emergency realm and search and rescue committee, that is a combination of a number of federal agencies. It's really supported by the U.S. Coast Guard, but it also includes the other Department of Defense agencies, NASA, and so on. You can see them listed at the bottom. They have this addendum for search and rescue that defines all of the procedures that they should be using to standardize search and rescue across jurisdictions. And if you look, here we go. If you look at the land search and rescue, that's the SAR responder, the primary location referencing system is the US National Grid. Now, it does say, though, that the secondary location referencing system is latitude, longitude, specifically in degrees, minutes, decimal minutes. And that's important because at least now we're standardizing the units for latitude, longitude. Now, if you look at the next line, aeronautical search and rescue responders, latitude, longitude is their primary location referencing system. However, the US National Grid is the secondary location referencing system for aeronautical responders. Now, the addendum further states, though, that any aeronautical resources that are supporting a ground-based operation will use the location referencing, the primary location referencing system of the ground-based resource, which is US National Grid. So we need to know both. And for all land-based operations, US National Grid is the primary location referencing system established as a standard. Okay, so now what we're talking about is having standardized maps. And this is about pre-creating maps. You know, it used to be the emergency manager would call me up, hey, I need a map that goes from here to here, shows this and that, and about this size. And we would go make that map. Well, what we're talking about is really creating a standardized set of maps that are available to everybody before the event and the training that they need to use those maps. So they have a map series that covers the entire area that they could be responsible for. Well, that means that there could be an operation that requires 2 maps or spans 2 maps. So now we've got 2 maps. Now we have these maps printed. We don't want to print millions of copies of these maps, but we should have a sufficient number of copies of these maps pre-printed and readily available, like in our emergency operations center. Our emergency manager should have it in the trunk of their car. The whole point here is that they don't need to wait for the GIS professional to show up after an event occurs to start using maps. They should already know how to use the maps. They should already have them in their hand so they can start. So it's very easy to teach them now that if you have an event that spans 2 maps, it's very simple to take the 2 maps, cut, fold, whatever you need to do, tape them together and put them up on the wall. And now you have a map, a wall map that covers your entire area. You can expand this with whatever number of maps that you need. Works very nicely. It's very easy. Doesn't take a GIS person to do it. You can have anybody, hey, we need a wall map. There's the maps. Put them together and give me a wall map. What this means is that now they start drawing on this map and show how their resources are being deployed or their understanding of the extent of the incident. And when we show up, now we've got a precision tool where they've started to capture all that information, as opposed to drawing it on a whiteboard or the back of or on a napkin or the back of some other piece of paper. We need to be able to pull the information off of the source that they've been using accurately. And when they're using a precision instrument, it's very easy for us to start to pull this stuff off and put it into a GIS database. Well, we've created these maps for the entire state of Minnesota. I'd certainly like to see Wisconsin do the same thing. A number of other states have also done this. This 1 to 24,000 scale works very nicely. So we've done this for Minnesota. These are all created as PDF files. It's very easy to create a map interface that allows you to go and select the maps that you need, or click on a square that represents the map extents and download an individual map. But you can also grab all of the maps that you need for the entire state or for your jurisdiction and perhaps the surrounding areas and put them on a thumb drive. So now you have them. In a worst case scenario, don't assume you have an internet. You can put all these PDF files on a jump drive. It's very easy to be able to give it to somebody, say, I need these files off of this thumb drive printed, and they can go outside of the affected area, go to a Kinko's or whatever, and print the maps that are needed. And it doesn't take a GIS person to do this again. Anybody can do it. The smaller maps, the 1-500 500-foot maps, we've created those for urban areas in the state. And again, a combination of aerial photo and then another one that has addresses and things like that. In Dakota County, we've put these together as map books by city. You've just got a library of PDF files. It's pretty easy to pull those together and create PDF, multi-page PDF files that represent the map book. So you've got a cover page and an index and all of the map book pages. And we actually did it for each page, for each facing page, you've got an air photo on one side and you've got a street map on the other side. Works very nicely. And you can have a street index in the back and things like that. But these are all available on a website. Somebody can just click on Apple Valley and they get the entire map book downloaded as a PDF file. These are all 8.5 by 11. Anybody can print them. In the same way, you can grab just the pages that you need. If we publish updated pages, they can just go grab the pages that they need, print those, and stick them in their map book. Very easy to manage, and the cost is very low. And again, we can download all of these, put them on a thumb drive, so we have them available in a worst case scenario. We also have the USGS US Topos. Those are available nationwide. These are National Grid compliant. They have a UTM grid on them. They're National Grid compliant. These are 7.5 minute by 7.5 minute quadrangles. They've been typically referred to as quad maps, 1 to 24,000 scale as well. These are GeoPDFs. I didn't mention all the maps that we've created statewide. The 10K maps and the 1K maps are all created as GeoPDFs as well. The US Topos are all GeoPDFs. They also have layers, so you can turn layers on and off once you've downloaded this PDF. So here, we've just turned the air photo off, so now we have all of the contours turned on. It really gives the user a poor man's GIS, being able to turn layers on and off. You can zoom in, grab the areas that you need. You can measure, get coordinate readout directly from these GeoPDFs. They're very, very useful. So what we end up with is a collection of PDF maps and PDF map books. We can automate the production. We create a library of PDF files, and we can create these PDF files very easily using ArcMap data-driven pages. ArcGIS Pro, it's called the map series. You set up the template for the map layout. You define the areas that represent all the maps you want to create. You push the button and all the maps get created. Go home, come back the next day and all the maps are there. And then we can even do, because of the logical numbering system, it's very easy to use things like Python scripting to create the map books automatically. So you just run your Python script and all the map books get created for you automatically. So we get these libraries of maps, and there are thousands of PDF files in these map libraries, but they're all numbered logically. You look at the name of a file and it represents the coordinates of the lower left corner. And not only that, if it's 2 digits, you know that it's a 1,000 meter square. If it's 2 digits, you know it's a 10,000 meter square. If it's 4 digits, you know it's a 1,000 meter square. So it gives you these map libraries that are transportable, standalone. You don't need any special software other than an Adobe Acrobat reader. You can print as needed and anybody can do it. There are also a variety of mobile apps that support the US National Grid. take your pick. You know, you go find GPS apps for your phone, and and go look in the settings for the coordinate readout, and look for US. It'll either be USNG, US National Grid, MGRS. MGRS is synonymous with the USNG. So look for the settings. Once you have the right setting, you're going to get the coordinate readout that supports US National Grid. Avenza PDF Maps is a pretty cool app that supports these GeoPDFs. The nice thing about this is that once you download a GeoPDF and import it into the Avenza PDF Maps app, it uses the map frame to show your location on the map. And so now you can actually track yourself on the map itself, and you can even do some rudimentary data collection, and being able to track where you are on the maps. It's free for personal use. There's a minor charge for business use, but we've published all of our parks maps out in the Avenza map library. It doesn't cost you anything to publish the maps, and anybody can go and grab a Dakota County Parks map, the same map that appears on our "You Are Here" signs, and they're all GeoPDFs. They can actually navigate using the Avenza PDF Maps app and our map. Find Me SAR is another app. findmesar.com. It'll show your location in USNG, MGRS, degrees, decimal minutes, so on. You can go ahead and look for that. Emergency location markers. This is a standard that we've created for these references in the field. So we have a sign like this at all of our trail intersections in the parks. We have what we call our "You Are Here" signs, because it's got a little arrow that says "You Are Here." But then we also put these blue signs that represent the US National Grid location for that. And we provide some basic instructions on how to use this. There is also an app. It's really not an app. It's a website that downloads an app to your phone in the browser, usngapp.org. You can play with that yourself. It'll show you your location in the same format as those location markers. And another app, which is an actual native app, USNG app. This was actually created by Esri. I do mention Share Geo there. Steve Swayze's got the next presentation here, and I just want to acknowledge all the work that Share Geo has done. They're a nonprofit here in Minnesota. Steve is the president of that nonprofit, and they're doing a lot of great work. They've really worked to design these emergency location markers. They created this USNG app. .org, and they've also been in consultation with Esri on taking over support for this USNG app as well. So they're doing a lot of good work. My USNG, that's another one. I'm sorry, My USNG is the Esri one that Shared Geo is taking over. The nice thing about this is it does include a map display. GIS Surfer is another free GIS that's out there, free for personal use again. The developer of this really has some interesting extensions for this that work well for property management, but he's really done a good job of embracing the US National Grid. It's a great way to just go look at US National Grid overlay for a given area. So just had some quick slides here that show how he changes the resolution of the grid based on your scale. So here we can say a 10 kilometer square, and then a 1 kilometer square. We get down to 100 meter square and a 10 meter square. And he also has some really nice documentation in here, and some good information about why the National Grid is important. He's done a good job of documenting all that as well. So it's a great resource. Encourage you to check that out. There's also other websites out there. They may not even say US National Grid. This is grid referencing. Any backcountry trekker, any backpacker that goes out into the mountains, they know how to do grid referencing because that's how you navigate. And so you can find other websites out there that have information and training about how to do grid referencing. And so here was one that I found. There are some that relate to military training. So anything that refers to the military grid reference system is good training for and support for the US National Grid. Here's another one, Army Study Guide. It's a private website, but it's really set up to help military personnel learn how to do grid referencing. And this is the U.S. National Grid. So again, this is nothing new. It's been around for a long time. It's taught in a lot of different forms, and there's a lot of supporting information out there. Iowa Task Force 1 has embraced this. They've created maps. Shared Geo actually worked to create maps for the entire state of Iowa, similar to what we did in Minnesota, the same 10K maps and 1K maps in the urban areas. But here what we have is the emergency management sector really embracing the use of the U.S. National Grid. And I point this out because they've created some training videos. And you can see this one's 8 minutes long. It's an introduction of how to use the U.S. National Grid for search and rescue. It's on YouTube, but it's a private YouTube channel, so you really have to go through the Iowa Task Force 1 website to get to the video, but I encourage you to find it. Google search will get you to Iowa Task Force 1, and then from there you'll find the video. And they actually have several different segments on the U.S. National Grid, and they're really short little videos that help provide an introduction to this. So there's a URL, but you can find it with a Google search too. Also, the Usngcenter.org. This is hosted by Shared Geo again. This is the definitive resource for learning about the U.S. National Grid. Shared Geo has really embraced the support for the U.S. National Grid and provided a lot of resources. And this website is really the key place to go for additional U.S. National Grid information. Encourage you to go there. If you go to, I think it's under, let me see, it's under, I think it's under Maps and Readers, but if you dig around there, you can find some instructions on how to make 1K maps. And we've got instructions that take you through step-by-step on how to create the maps. The MXDs can be downloaded. It takes you through downloading all the supporting data that you need, shows you how to use data-driven pages in ArcMap to create the maps that you need. Also, NAPSG, that's the National Alliance for Public Safety GIS Professionals. They've created a number of resources. If you go to their website and look up or look for U.S. National Grid resources on their website, you scroll down a little bit, there's a map template for creating USNG map books in ArcGIS Pro. And this actually takes advantage of the ArcGIS Pro tasks. And so it'll step you through downloading the data, which is available as a national resource, and then steps you through creating the maps for any area. So I encourage you to check that out. Also, the U.S. National Grid Wikipedia page. Steve and I are both involved in a national implementation working group for the U.S. National Grid. We have a number of people working nationally to assist in promoting the use of this. And somebody went in, volunteered to take on the Wikipedia page. It was really not very good, I guess. And he fleshed it out and provided a lot of cross-linking between the different resources that are out there and linked to a lot of good information. So you can go to the U.S. National Grid Wikipedia page, and there's a lot of good stuff out there as well. Esri's providing a lot of great support for the U.S. National Grid. This is good to see. It took them a while to come along, but there's a lot of great stuff out there now, even just in ArcMap and certainly in ArcGIS Pro. ArcGIS Pro does a very good job of supporting the U.S. National Grid and MGRS. It used to be something that was supported through the military extension for ArcGIS, but they really embedded some of this stuff directly in their products. There is a feature service out there that will do a grid overlay that was provided by the NGA. There's a number of other enhancements that they've added, like to the World Geocoding Service, where you can enter a U.S. National Grid location and it'll find it on the map. The grid overlay widget for Web App Builder that came out about a year ago. Really slick. You can just create, when you're creating your Web App Builder application, you add the grid overlay widget, and it'll show the grid to varying degrees of precision as you zoom in, just like what we saw with GIS Surfer. So momentum is building locally and nationally. We can see a number of states that have national grid maps now. That slide or that capture in the lower left corner is outdated. You know, we do have maps for all of the state of Minnesota and Iowa. I'm sorry that I didn't update that, but we're really working with Shared Geo to create an interface where anybody that creates maps that are available, U.S. National Grid compliant maps that are available on the internet, would be able to register their maps, that map location, with an application on the Shared Geo website, and all of the maps would automatically, the map extents would automatically display. And so that's an ongoing effort, but we're really starting to see a lot of jurisdictions embrace creating these standardized maps.
Hey, Randy, you have about
Yeah.
4 minutes left.
This is my last slide. So kind of a corny in your face thing, but you know, this is a national standard. It's been around for a long time. It's taking a while for everybody to embrace it. But you know, this isn't something where we get to decide whether or not we want to do this. It's a national standard. We're obligated to do it. And you know, I'd really ask you as GIS professionals to think about this as a way to open the door to having a conversation about what you can do with your emergency managers and your first responders. It's in the FEMA documentation now. They have requirements to provide U.S. National Grid locations for critical infrastructure. And this is a way that we can say, well, that's what we do. And then when we create maps that are compliant or further support the U.S. National Grid, it just enhances the kinds of the capabilities that we have, and we can build on that, you know, starting to provide the situational overlays on top of the same maps that they already know how to use. So really, this is something where we need to, as GIS professionals, we need to own this problem. We need to embrace it ourselves. We should not be questioning it. We should do whatever we can to support it and promote it. And like I said, it's a great opportunity, a door opener with the emergency management, emergency response community to start the conversation about what we do and provide them with the minimal capabilities in having pre-created maps and know how to use them, and then be able to provide the additional support with all the other cool stuff we can do. So with that, if I had a couple minutes, I'd be happy to answer any questions.
If you have any questions, you can put them in the chat and we will try to get those answered as quickly as we can. Thank you, Randy.
Okay, thank you. Thanks, everybody.